Hi everyone, in Algebra 3. Today we're going to be going over your new material on lesson 77, which is on something called binomial expansion. So what this basically is going to be a way that we can expand something without actually having to multiply it out by hand. So what you're going to look at is you'll have a first term and then you'll have a second term. And notice that the first term always starts off with the highest power, and then the second term starts off with the lowest power, and then they go in opposite directions. So from the first term, it starts with the highest power to the lowest power. The second term from the lowest power to the highest power. Lowest power is always to the power of 0. So you can always come up with your exponents based off of this binomial expansion. And then to come up with the coefficients, you're going to use something that we call Pascal's triangle. This will give us the coefficients for each of those terms. Now, this is what Pascal's triangle looks like. So I'm just going to choose to focus on, let's just look at one part of this. So let's look at the top couple. So if I look at the first row, this would be anything to the power of 0, or a plus b to the power of 0. The only coefficient would be 1 because anything to the 0 is 1. The next row would be more 1, so that would be a plus b to the power of 1. Then from there, this would be for the power of 2, 3, 4, 5, and 6. So it kind of tells you what power it is. And the way you draw this triangle is actually just by addition. So 1 plus 1 is 2. Then 1 plus 2 is 3, 2 plus 1 is 3, and the outsides are all going to be 1. So you actually can create this table just by addition, and that is called Pascal's triangle. So if you would like to look that up to get a better look at it, it's called Pascal's triangle. So now what I'm going to do is I'm going to do numbers 1 through 15 with you, but I would like you to attempt these first before you actually do them or check with me to make sure it is right. So we can just go through this slowly. You'll just do you can pause the video, do number 1, then unpause, and then we'll just go through the whole entire lesson, or numbers 1 through 15 like that. Okay, so number 1 comes from, I think, lesson 76. It's how many different 5-player basketball teams could be formed from 9 players. Assume that anyone can play any position. So for number 1, we're going to be choosing from 9 players chosen 5 at a time. And that formula is going to be 9 factorial over 9 minus 5 factorial, and then 5 factorial. So it's n factorial over n minus r factorial, and that would be 9, 8, 7, 6, and then 5 factorial. And then this would be 4 factorial, so that would be 4, 3, 2, 1, and then 5 factorial. The 5 factorial will cancel. Then you can do 3 times 2 is 6. 4 goes into 8 2 times. So we can multiply this out as 9 times 2 times 7. And that would give you 126. Okay, now moving on to number 2, we have on a 600-mile trip, the traveler traveled 50 miles per hour for the first 1/3 of the trip, and at 40 miles per hour for the rest of the trip. Sorry. What was the traveler's average speed for the entire trip? Okay, so we have number 2. The first 1/3 of the trip, the distance, we would divide the 300 or 600 by 3, which would give us 200 miles. And the rate would be 50. So therefore the time would be 4. Distance 2 would be the rest, so that would be 400. But this is going to be at a rate of 40. So that means time would be equal to 10. Now it's asking for the overall rate. Overall rate is equal to the overall distance, which is 600, divided by overall time, which would be 4 plus 10. So 600 divided by 14 is not going to be an even number. So I think that would be 300 over 7. Or 42.86. So overall rate is equal to overall distance divided by overall time, and we actually had to evaluate for that overall time. And now we're going to be looking at number 3. So number 3, we have Tweety Bums sell for $200 each, but students get a 12% discount. If students pay in cash, the student price is reduced 6% of the original price. What would a student who paid cash have to pay for 4 Tweety Bums? Okay, so this would be $200 times 0.12. That would be the discount, the student discount. So 200 times 0.12 gives us $24. So this would be the student discount. And then the discount for paying cash would be 6%, which is 12. So this would be the cash discount. So in total, you would get 36 off of the 200. So you would pay $164 per Tweety Bum, and she is buying 4. So your answer should be $656. Now looking at number 4, we have the city has an assessed valuation of $6,400,000. The rate for school taxes is 80 cents per $100 valuation. If all 2% of the taxes have been collected, how many dollars have not been collected? Okay, so we have to figure out for number 4, we have $6,400,000 dollars, and that would be 80 cents, so 0.8 for every $100. So $6,400,000 divided by 100 times 0.08. Oops, that was wrong. Sorry, $6,400,000 divided by 100 times 0.8, because it's 80 cents, would be 51,200. And we've collected, if all 2% of the taxes had been collected, we would just need to multiply this by 0.02%. And that means that $1,024 has been collected. So $1,024 has been collected. Now moving on to number 5. So we have 3 consecutive positive integers such that the product of the first and the third exceeds the second by 19. So consecutive positive integers means we have n plus 1, then n plus 2. The product of the first and the third, so that would be n times n plus 2, exceeds the second, which is n plus 1, by 19. So I'm going to set this equal to 0, so that would be n squared plus 2n minus n minus 20 equals 0. So n squared plus n minus 20 equals 0, and that factors evenly into n plus 5 and then n minus 4. So my 2 answers for this problem would be n is equal to negative 5 or n is equal to 4, and it says that it's consecutive positive integers, so that means my only answer would be 4, then 5, then 6, because negative 5 is not a positive integer. Now looking at number 6 is just another concept review problem. So if x is an odd number, what is the quotient of the next greater odd number divided by the next greater even number? So for number 6, if we have an odd number, to get to the next greater odd number, you're going to add 2. And that's divided by the next greater even number, which would be plus 1. So if you're at an odd number, to get to the next odd, you would add 2, but to get to the even number, you would just add 1. So that'd be x plus 2 over x plus 1. Now number 7 and 8 are going to be our new problem. So I do want you to, we're going to actually draw up Pascal's triangle for this. And I want you to attempt this. Actually, I'll just do this one with you. So number 7, so for x plus y to the 4th, x is your first term. So that's going to start at the highest power, which would be x to the 4th and y to the 0. The next one goes to x to the 3rd, then y to the 1. Then x to the 2nd, y to the 2nd. Then x to the 1, y to the 3rd, and the last would be y to the 4th. Now I have to find those coefficients. So when I'm starting with Pascal's triangle, I start with 1, and then 1 and 1. This would be to the power of 0 to the power of 1. Then I'm going to add down. So this would be 1, 2, 1. Outside is always 1. Add those. 3, 3, 1. Adding again, 3 plus 1 is 4, 3 plus 3 is 6, then 4 and 1. Adding again, 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, 5 and 1. Okay, so these are actually your coefficients for your power of 5. I went too far because I only needed the power of 4. So this would be your coefficient would be 1, then 4, then 6, then 4, then 1. So this right here would be your answer. Now, that extra work did not go to waste because for number 8, we actually need the power of 7, and we're only looking for the third term. So what I'm going to do is I'm going to do 1 plus 5 is 6, 15, 20, 15, 6, and 1. The last one we'll need is 1, 7, 21, 35, 35, 21, 7, and 1. And we're only looking for the third term. So 1, 2, 3. So for my first term, it would start with the highest power. So that would be x to the 7th, and then 6, and then 5. So it would be x to the 5th. And then for the second term, it starts at 0, then 1, then 2. So it would be x to the 5th, y to the 2nd, and the coefficient would be 21. So again, your first term starts at the highest power, your second term starts at the lowest, which is 0, and then you would just go 3 into it because we're looking just for the third term. Okay, now looking at number 9, and number 9 is the proofs that we learned in lesson 76. So you start with the left, and then you want to end with the right. And if you have your notes from this lesson, I would grab those because you probably don't have them memorized yet. So I'm going to do sine x times secant x. Secant x I know is the inverse of cosine. So sine x times 1 over cosine x, which would just be sine x over cosine x. And from your notes, sine x over cosine x is actually equal to tangent x. So the left does in fact equal the right. So I would have your notes out for numbers 9, 10, and 11 because you probably don't know what all of those are equal to yet. Okay, so for number 10, I'm going to start with the left. So secant x cotangent x is going to be equal to secant is the inverse of cosine, so 1 over cosine x. Cotangent would be cosine x over sine x, because tangent x is sine over cosine, cotangent's the inverse. You should see that the cosines cancel, so you're left with 1 over sine x, and that's equal to cosecant x. So the left does equal the right after some manipulation. Now for number 11, I have sine of negative theta times tangent of 90 minus theta. Sine of negative theta is actually equal to negative sine of theta. Tangent of 90 minus theta is actually equal to cotangent of theta. Cotangent theta is equal to cosine theta over sine of theta. So you should see that the sine thetas cancel, and you are left with negative cosine theta. So the left does in fact equal the right after some manipulation. So if you remember your 2-column proofs, it's kind of like a throwback to that. Now looking at number 12, we need to solve using Kramer's rule. So we are going to start with our matrices over matrices. That first one will be x. Second one's going to be y. Remember, we have an x column and a y column for our coefficients. So for the bottom, it's going to be 4 and 3 for the coefficients of x. Then for y, it's -2 and -1. And both these denominators are going to be the same. So 4, 3, -2, -1. Now, if you're solving for x, you're going to change this x column to what the equation is equal to, which is 6 and 7. The y column stays the same at -2, -1. Now, if you're solving for y, the y column is going to change. The x column stays the same at 4 and 3. The y column is going to change to what the equation is equal to at 6 and 7. Now you're going to multiply, so top left times bottom right minus top right times bottom left. So that would be 6 times -1 minus -2 times 7 over 4 times -1 minus -2 times 3. So that's going to give me -6 plus 14 over -4 plus 6. So that's going to be 8 over 2 equals 4. So I know that x is going to be equal to 4. Now I'm going to solve for y. I already know the denominator is going to simplify to 2, so I just need to do the top. So that will be 4 times 7 minus 6 times 3 all over 2. So 28 minus 18 over 2, 10 over 2. So that means y is going to be equal to 5. And that's number 12. Now number 13. So what is the radius of the circle that can be circumscribed about a 6-sided regular polygon whose perimeter is 36 centimeters? What is the radius of the circle that can be inscribed in the regular hexagon? So they're asking for two things. If I have a 6-sided, I'm going to have 1, 2, 3, 4, 6. And then each side is going to be 6 because the perimeter is 6. We want to find the radius of the circle that can go on the outside. Which would be the slant. And then we also want to find the radius of the circle that can be drawn on the inside, which would actually be the height. So we're looking for two things. Now I'm going to draw one of those right triangles where the base is going to be 3, because if the whole base is 6, that means the right triangle base would be 3. This would be the radius of the inscribed triangle. This would be the radius of the circumscribed triangle. We need to find this angle, which you just do 360 divided by the number of right triangles, which is always double the number of sides, and that's 12. So we get 30 degrees. So now to solve for the radius of the inscribed triangle, I'm going to use tangent. So tangent of 30 equals opposite over adjacent. So RI is going to be equal to 3 divided by tangent of 30. So 3 divided by 30 tangent equals, and I get the radius of the inscribed triangle is going to be equal to 5.20. Now for the radius of the circumscribed triangle, I'm going to use sine. So sine of 30 equals opposite over hypotenuse. So RC is going to be equal to 3 divided by sine of 30. And I get 6. So the radius of the circumscribed triangle is going to be equal to 6. So we have an inscribed, which is equal to 5.2, and the circumscribed, which is equal to 6. And that's number 13. Now number 14, we are going to be solving for side A and angle A, which angle A we should be able to solve for right away because we know that the triangle adds up to 180 degrees. So to solve for angle A on number 14, I'm going to do A is equal to 180 minus 120 minus 30. So A is going to be equal to 30 degrees. Now I can set up my ratio. All I need is the A over sine of 30 equals 10 If this angle is 30 and this angle is 30, that means that these sides are going to be equal to each other. So that means A is going to be equal to 10 centimeters. So you actually didn't need to use the law of sines for that one. You could have actually figured that out without using a calculator. Then lastly, number 15, we have to change this into standard form. So what I'm going to start by doing is dividing everything by 16. So I have 8x squared over 16 plus 2y squared over 16 equals 16 over 16. So that's going to be x squared over 2 plus y squared over 8 equals 1. Now this one is not going to come out evenly, so I'm going to have to take the square root of both. And then I'm going to graph that. And you can just estimate that. So square root of 2 is approximately 1.4, so that'll be over approximately this much. Then the square root of 8 is 2.8, so it's almost 3, so that's almost to 3 on top and bottom. And then you're just going to connect your dots. So it should look something like that. And that concludes the problems that we're going to do from lesson 77. I hope that got you a good start for your stamp, and I hope you guys all have a great day. Bye.